Welcome everybody. What if I told you that a single Bitcoin miner plug-and-play machine in your spare bedroom could outperform a multi-million-dollar data center? In 2026, the Bitcoin mining lottery is evolving and is officially more lucrative than ever for solo players. In this episode, I'm breaking down the exact strategy to maximize your odds and be that next solo miner to hit that next Bitcoin block. Okay guys, welcome back to the channel as always. So in this episode, it's going to be leading on from the previous three, and we're now going to be looking at solo mining pool probability. Now, if we go back 3 episodes, we first looked at starting our own Bitcoin node in Umbral OS. Then we went on to looking at how to use a Bitaxe. And then in the most recent episode, we looked at tying that all together and solo mining to our own Bitcoin node using public pool and that Bitaxe. Now, following on from that, we're going to look at and break down what are your chances of actually mining the next Bitcoin block. What is the probability of that based on any given hash rate? So you can see the hash rate on the screen here. That's what we're going to be starting to look at initially. Then we're also going to move on and look at the probability of finding at least one block in 30 years. So that in theory should give you enough time to find a Bitcoin block. Then we're also going to look at solo mining pools and their days until they next find a block. That's going to include the main pools, as you can see on screen here, like Parasite, public pool, Atlas pool, node runners as well. Now, we're also going to look at some charts, as you can see on screen here. This is going to show you the days until they will find a next block. And then finally, we're going to move on in part 2 to self-hosting and what can you do to increase your chances of being the next miner that finds that Bitcoin block. We're going to look at the top 5 most important mempool policy settings for your Umbral node. We're going to look at the top 5 priorities for fastest template serving to go from your node to your private public pool instance. We're also going to look at proof of template creation via the RPC Explorer, as you can see on screen here now. And we're also going to look at proof of public pool receiving those templates, as well, as you can see on screen here now. And then finally, we're going to look at wrapping that up in command prompt to confirm that public pool is indeed receiving those templates. Also, guys, I would love to know, are you running a private instance of public pool? Let me know in the comments what your pings are like, and if you've got any concerns or questions about your chances of finding the next Bitcoin block, I'll try to answer them as best as I can. Okay guys, now to kick off part 1, let's look at solo mining odds. How long would it take you to find a Bitcoin block using the data on the table in front of us for any given hash rate, right? Now we know at the moment, so the network hash rate is around 980 exahash, as it says on screen there. So quick takeaways, even a petahash or 1000 terahash was still looking at 18.6 years on average to find a block. Then 200 terahash is roughly the point where it drops under 100 years. The relationship is perfectly linear. Doubling your hash rate exactly halves the odds. So let's have a look now. Let's start off with 5 terahash. So your odds per day, 1 in 1.36 million. Then if you double that, the odds halve, 1 in 680,000. And if you double that again, obviously the odds half again. So 1 in 340,000 and so on, right? Until you get to the point around 1000 terahash or a petahash. So you have a chance per day, 1 in 6,806, or you would expect to find a block once every 18.6 years. So it's at that range that actually block finding becomes potentially feasible within your lifetime, or let's say over 500 terahash, right? Because that is per day a 1 in 13,611 chance, or expected years to find one block at 500 terahash, 37.3. So again, depending how old you are and where you are in your life, though, that's the level or the threshold at which it's potentially feasible. You could say, if you set yourself up with that amount of hash rate, yes, I have an extremely solid chance of finding a block within my lifetime. Okay, and you can just see the probabilities on screen there as well. So pause the video if you need to, go through that there at your own leisure. I hope that gives you a really good overview of the different levels of hash rate, i.e. 5, 10, 15, 20, 25, 30, and so on, up to 1000, and also the expected years to find one Bitcoin block. Okay guys, now next up, a slight variation on the previous table. So this time, it's your probability of finding at least one block in 30 years. Now, depending on your age, this is going to be more or less relevant, okay? But I would hope that most people watching that video would be at the age where if you gave yourself 30 years, that would be enough of time to find a block and for it to make a difference in your life in terms of the financial reward you would get for doing that, right? So if we just look at the hash rate, we've got 200, 300, 400, 500, 600, 750, and 1,000. And you can see there, expected years to find one block comes down as you increase, right? So we get to the point where by 1,000 terahash, again, you're looking at 19 years. And for 750 terahash, you're looking at 25 years. And for 600 terahash, you're looking at 32 years. So depending on what your age is, maybe for myself, this is probably over above 500 is probably the cutoff where I'd be saying, okay, if I set up with 500 terahash today and I found a block within 38 years, I'm still young enough for this to make a decent effect and impact on my lifetime, or on my financial life, I should say. Okay. And then if we just look at this realistic verdict, you've got long shot, possible, decent chance, slightly likely, good chance, likely, and very likely. So it's really above 500 where you start to say, yes, I have more than a 50% chance. So effectively a coin toss. You've got more than a flip of a coin's chance of getting a block within your lifetime, right? Which is quite encouraging if you've got the financial means to do this, or maybe you can rent Hashrate. It's certainly something looking at, okay? And again, these programs are where we break down the odds so you can really understand in clearly refined detail what your options are moving forward. Okay guys, so just moving on slightly now, still staying on probabilities and time to find a block, but this time we're looking at solo mining pools rather than solo mining on your own node. So on the right hand side, we've got the data for probability, chances, and pools. So as you can see here, the probability is there in percent, 5, 10, 15, and so on. And then we've got Parasite pool here, where the 7-day moving average of their hash rate is around 160 petahash. And then based on that hash rate versus the overall network hash rate, we can deduce that they would basically have a 5% chance of mining another block within 2.2 days from the 20th of April. And you can see the dates going down here. I'm going to explain a little bit in a minute or two why this row is highlighted here at 63.2%, which takes them to the 31st of May, when we would expect them potentially to find another block, or at least say it's highly likely that they could find a block by then. And the reason we've highlighted 63.2% is on the left-hand side of the screen. Okay, so let's just go through the text and break down what it's trying to tell us. So when we wait exactly one mean, so expected waiting time, the probability that you've already found the block is always around 63.2%. This is true no matter what the actual mean time is. Now for Parasite pool, the mean would be 86.8 days, or after 86.8 days, the probability is 63.2% that they would find a block. For Atlas pool, a much smaller hash rate means 1,900 plus days, or after 1,900 plus days, the probability is still exactly 63.2%. For a giant pool or even the whole network, again, 63.2%. Okay, now to expand on that a little bit, and where's that value coming from? So what it says here, this is not a universal property of the exponential distribution, which the Bitcoin mining process is based on, guys. It's not the mean probability. The probability itself is not always 63.2%. It changes with time. I appreciate this is probably sounding confusing, but this is why I'm going to try and break it down into bite-sized chunks, and then we'll go through it bit by bit. After one day, the probability is very small, but after 10 years, the probability is almost 100%. So what you're going to see in a couple of minutes when we go through the charts, if you imagine on the left-hand side, you've got the line at a very low rate. And then as you go towards the right-hand side, it increases dramatically the further you get towards the right-hand side, which would be 100%. So it's heavily weighted towards the right-hand side, i.e. exponential. So a simple way to remember it, at the mean waiting time, you have a 63.2% chance of success always. The number comes from 1 minus 1 over e and never changes for any exponential process, whether it's mining, radioactive decay, bus waiting times, etc. Now, where does this value come from? So this is based on something called Euler's number, which pops up, as it says here, in all kind of processes, whether it's mining, radioactive decay, or whatever. And it just means that the mean amount of waiting time for a block to be found is 63.2% of the time. Hope that makes sense. We'll go through it again in a little bit when we look at the charts in the table, okay? Now, if we use Parasite as the example here, so Parasite Pool found their first block on February the 28th, 2026. According to the network hash rate at that time, they should have waited on average 86 days before finding the next one. But they found their second block only 49 days later on April the 18th. So that's significantly earlier than expected. They got lucky. So why does this happen? Because Bitcoin mining follows an exponential distribution, guys. Most people assume that if the average wait is 86 days, then after 86 days, you should have found the block, but that is not how it works. After exactly one expected waiting time, in this case 86 days, you actually have a 63.2% chance of already having found the block. Why 63.2%? Here we go, guys. Let's dive in. It comes from the formula 1 minus 1 divided by E, or Euler's number. Euler's number is a fundamental maths constant, roughly 2.71828, that naturally appears in anything involving continuous growth or decay, including radioactive decay and mining probabilities. The 63.2% number is universal. It doesn't matter if you're a giant pool or a tiny solo miner. When you reach the expected time, your success probability is always 63.2%. Now, some blocks may come well under that, as in the case of Parasite Pool's 49-day wait. Okay, some blocks may go over the 63.2% chance, right? So they would be blocks that have come later or past the expected time of arrival. But the mean average time is 63.2% chance. You would expect at the 63.2% chance, you would expect to have found a block. Again, that's not a guarantee. It's not a prediction. It's based on this mathematical constant, as it says here above. So just move on. Now, Parasite Pool's hash rate has increased dramatically since they found their first block, guys. As you imagine, a lot of people have piled in. Now, when they found that first block, I believe the 7-day moving average was around 80 petahash, okay? And now, if we look at this data here, you can see the 7-day average is around 153 petahash. So it's nearly doubled, right? Now, that changes the maths quite dramatically, because if we look here at the text on the left, it says that's also why the true 50-50 point, so the median, not the mean, the middle point, is only 30 days for Parasite Pool, not 43.4, which we're going to see on the table now, right? So if we highlight this row here, 50%, or for them to have a 50% probability of mining another block from the date they found it, okay, which would have been the 18th of April, they would have to wait another 30.1 days, which gets them to around the 18th of May. Or if we choose 63.2%, which is the average point that pools find blocks at, so that's 63.2%. Again, some come earlier, some come later. The wait time would be 43.4 days, which would put them at the 31st of May. So we're on the 12th of May today, date of recording. So we'd expect roughly their next block either to come slightly earlier. So I suppose any time from, maybe now really, any time from now, because tomorrow would be the 13th, which is this day here. Okay, so that would put them at 26 days. And then 50% would put them at 30 days or the 18th. 55% would put them at 34.7 days or the 22nd. 60%, you get the idea, 27th, and so on, right? So probably expect them to next find their block on the 31st of May by following this kind of distribution curve, or they could end up well past it. They might go until the 26th of August until they next find a block. Okay, guys, so that was solo mining pools and days until next block based on probabilities. We're going to elaborate on the data here, and we're going to look at some charts now, and hopefully the concepts and what we've covered, the probability, Euler's number, they'll start to sink in a little bit more just by viewing them graphically and visually. Okay, guys, so let's go through the charts. Now, we've got time until next block by mining pool, as it says here. On the left-hand side, we've got the number of days on the y-axis, and underneath here on the x-axis, we've got the percent probability that they found that block within a certain amount of days. Now, the green line, as it says here, is the mean wait time, which is at 63.2% that we've been banging on about throughout this episode. Now, in blue, we've got public pool, which at the time of recording has around 47 petahash. And then in the white, we've got Parasite. Again, time recording had around 160 petahash. So that's what this data is based on. Now you can see the mean wait time for Parasite. You can see it visually here instead of looking at a table. Now it is around 43.4 days. so just over a month, and for public pool is around 150 days or around 5 months. Now, if we look at the right-hand side here, so what we said earlier, you get that exponential curve, which just comes from the fact that the longer you wait in the amount of days here on the left, the higher the probability gets. And there's a large amount of data in what we call the long tail, i.e. it's heavily weighted towards this side because the longer you wait, the higher the probability, okay? Now, we can see that for Parasite's previous block, they were extremely lucky. I think they came in at around between 45 and 50% chance, which at the time, because they had 80 petahash, put them at around, I think it was 50 days, okay? So they were extremely lucky. And if we just move on to the next chart, we've then got Atlas Pools for a smaller amount of hash rate, 9.21 petahash. For Atlas Pool, it would take them around 754 days, okay, or around 2 years to find a block. However, again, that could come later, could be any of those values on the chart there, or conversely, it could come earlier. And in the case of Node Runners, which is the final chart we're going to look at, they were extremely lucky. So their block came in around about here, I believe. So they only had a 5% chance of finding that block. So that just shows you, because the luck can vary. There's a massive variance in luck and the amount of days that you'd have to wait based on hash rate. We can tell by looking at the figures of the mining pool and the total network hash rate when they should find a block, but it doesn't always mean they will do due to the random variance of the network. Some blocks can come over, i.e. here, and some blocks can come under. So that was the chart. Let's go back to the table data next. Okay guys, now that we've looked at the chart, let's just hop back to the probability data and this text on the left-hand side for a minute or two. So in theory, the 31st of May, as it says here, is not the date Parasite Pool should hit their next block. It's simply the date at which the probability reaches 63.2% that they have already found it. Now, if we look at the data from this table, so milestone, current date today, it says days from the 18th, 23rd, right? Calendar date, 11th of May. 41% chance they've already found it. Now, the median point, 50-50, would be 30 days, and that would be the 18th of May. The mean chance, 63.2%. Again, that's where the majority of the values for finding blocks would occur. That's 43.4 days. That would take us to the 31st of May. It says after this date, you have 63.2% chance that they've already found block. What does this really mean? So there's still a 59% chance as of today that Parasite Pool has not yet found their next block. They could easily find one tomorrow, in 2 weeks, or go past the 31st of May without a block. All of that is completely normal under the exponential, distribution. The 31st of May date is not a prediction. It's just the mathematical point where 63.2% of all possible outcomes have already succeeded. Even at the expected time, there's still a big chunk of probability mass in the long tail. So that would be the bit on the chart we looked at a minute or two on the far right side at the upper portion of the chart, where that curve is just going up, 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 and up really steeply. So realistic expectations right now. Parasite is running at nearly double the speed, so 160 petahash, so they're due for a block sooner rather than later compared to before. But crucially, sooner still means anywhere from the next few days up to a couple of months, with the 31st of May being the 63.2% marker. So I hope that all made sense, guys. For me personally, it gives us a really fascinating insight into just how probability works with finding a Bitcoin block on these solo mining pools. And you can certainly get more of an insight into when to expect them and how long these pools should have to wait based on their hash rate for another block to be found. Okay guys, now just to summarize, so for part one, the 63.2% rule, what does that mean? In Bitcoin mining, when you reach exactly one expected waiting time, you actually have a 63.2% chance of already having found the block. This is a universal property of the exponential distribution. It's always 63.2%, whether you're a tiny solo miner or a giant pool. And if we look at Parasite, so they were supposed to wait on average 86 days after the February block, but they hit one in only 49 days after that. That's lucky and completely normal because of the exponential curve we looked at in the chart, guys. Most people wrongly think the average is when you should find it, but that, as we can see on the right from the table data, is not how it works. So why 63.2%? Again, to summarize, it comes from the maths. 1 minus 1 over E, Euler's number equals 2.718. This same number appears in radioactive decay and many other random processes. It's also why the true 50-50 median, again, which we can see on screen here on the right-hand side, is only about 69% of the expected time. Okay, don't pool hop. Right, this is important because the process is memoryless. That's so important to remember. The chance of any pool finding the next block is exactly the same, whether they found their last one yesterday or 80 days ago. Hopping based on overdue pools doesn't improve your odds, it actually hurts you. In terms of where Parasite stands now, with their current 160 petahash rate, there's only a 63.2% chance they've found their next block by the 31st of May 2026. Right now, so the 11th of May, there's still a 59% chance they haven't found it yet. They could hit one tomorrow, in 2 weeks, or go past the end of May. All of that is completely normal. Okay guys, that brings us to the end of part 1 for solo mining probability. Look out for part 2 in 4 days time, or check out the solo mining probability playlist now. Thanks for watching. As always, you know I appreciate it. Stay ahead, stay decentralized. I'll see you in the next one.